Hare Krishna. We are going to see how to apply the Prim's algorithm to obtain minimum spanning tree. Here the graph with 5 vertices has been given to us. The first step towards finding the minimum spanning tree is to initialize the distance and status of all these 5 vertices. So distance of these 5 nodes is initialized to infinity, as it is told in earlier videos too, that this infinity is not representing the largest distance. Instead it is representing that distance is unknown initially, and it is to be calculated. So as we progress further, this distance is going to be updated. Second is the status. Status represents whether this respective node is processed or unprocessed. So it just avoids us entering into the loop by revisiting the nodes. So when we find that the node is processed, we move with the another node. Step 2 is to select the source node. Here we have selected A as a source node and its distance is made 0. One more variable we are going to keep track of, that is the parent node. So parent is keeping record of the predecessor node of the process node. So as A is the source node, its parent or predecessor node is set to -1, as it is not having any parent or predecessor node. So initialization looks like this. A is a source node, so respective distance and status is 0. And for B, C, D, E, for remaining nodes, distance is infinity. All these nodes are to be processed, so rightly their status is 0. A is having parent -1, which represents that A is not having any parent or predecessor node. Third step is iterative in nature. As minimum spanning tree or any spanning tree involves only v minus 1 number of edges, this step is to be performed for v minus 1 times. As we are having 5 nodes, 4 times this step is needed to be repeated. So with every step we are going to select the unprocessed node with minimum distance, say u node, and whatever v nodes reachable from this u node, their distances are going to be updated. So with this first iterative step inside step 3, we are going to select the A node, which is with minimum distance 0, and we will set its status 1 as it is being processed now. Now the nodes which are directly reachable from A are B and C. So that is clear from this diagram. The B and C, these are directly reachable from this A, and these are lying at distance 2 and 5 respectively. So as 2 and 5 these distances are less than infinity, we can replace this infinity by 2 and 5. And for this B and C, the predecessor node becomes A, because these are reachable from A. Now with the second iterative step, we are going to select this B node as it is with the minimum distance and which is to be processed. So as it is selected, its status is updated to the 1. Now from B, these are the nodes which are reachable, C, D and E. So now the C node is lying at distance 6 from the B, whereas currently C is holding 5. As 5 is less than the 6 distance from the B, we are not going to update it. It is going to retain this 5 value and its predecessor node remains A itself. Okay. Next node which is reachable from B is the D node, which is at distance 8 from B. Since D is holding infinity with the previous iteration and 8 is less than infinity, this infinity is getting replaced by this 8 and its predecessor node becomes B. What it indicates that D is now reachable from B. Similarly, E is at distance 15 from B, and with previous iteration it was holding infinity, so this 15 is used for replacing this infinity. Its predecessor is also set as B. Moving further, as I said, with every iteration we are going to select the node with minimum distance and its status should be 0, which indicates that it is unprocessed node. So remaining nodes which are to be processed are C, D and E. So among these three nodes, C node is with minimum distance and it is unprocessed too. So with the third iterative step, C has been selected and its status is updated to the 1. Now we will check for the nodes which are directly reachable from C. So here from C, A, B and E, these are the nodes which are directly reachable, but of which A and B have been already processed. So so its distance has been already finalized, so we cannot update its distance. Now remaining node is the E, which is lying at distance 10 from C, and rightly E is holding 15, which is greater than the 10 distance from the C, so it is going to be updated to 10, and its predecessor also gets replaced by C. Next, with the next iteration, we have only two nodes which are unprocessed, D and E. So of which D gets selected as it is with the minimum distance and its status gets changed to 1. Now we will see which are the nodes directly reachable from this D. So from D, B and E, these are only two nodes which are directly reachable. Now of which B has been already processed, so we cannot update its distance. Only E is remained, and which is at distance 4 from D. So as 4 is less than 10, this 10 is going to be replaced by 4, and corresponding to that, this predecessor node is updated to D. So what it indicates that D is the predecessor of this E. So this is how the iterations are over, and we can construct the minimum spanning tree by using this parent variable. So here it starts with the A node because its parent is -1. For B and C, parent node is A or predecessor node is A. So that is what shown here. For D, predecessor node is B, and for E, predecessor node is D. We can put its respective distances in order to calculate the cost of minimum spanning tree. AB is 2, AC is 5, BD it's 8, and DE it's 4. So 2 plus 5 plus 8 plus 4 is 19. This is what the cost of minimum spanning tree. Okay. So that's how this Prim's algorithm can be applied in order to obtain the minimum spanning tree. Thank you.